So this is the start of the last unit. We're going to be talking about sinusoidal functions. Before we do that, we're going to introduce this by talking about what a periodic function is. Okay, a periodic function is something that repeats over and over again. If you think about the graphs we've done so far, we've got lines, we've got parabolas, we've got cubic functions, we've got log functions, etc. None of these repeat over and over again. They have a specific shape and you get to see them. The sinusoidal functions have a specific period. Okay, so let's take a look at some of these graphs and decide which ones have repeating patterns. Alright, you've probably all watched enough movies or shows where they have EKGs, or the heart rate monitor, and if you think about them, though, you're gonna see this kind of stuff over and over again. There's a pattern that repeats if there's a steady heart rate. Okay, this is periodic because there is a section of the graph, a period, that will repeat over and over and over again. And from that, we can make predictions about what should be coming up next. Of course, unless all of a sudden heart rate changes, but a steady heart rate or a normal heart rate would repeat over and over again. So this would be periodic. Okay. Oops, my pen's not working. Okay, let's try the next one. This one is a child on a swing. So if you picture swinging back and forth, every time you're going to go up and then come down, up and come down. And as you swing and you gain momentum, you're going to go higher and higher in the air. And that's what you see here in this graph. Each swing, you go up higher and higher. There's obviously going to be a limit. You're not going to be able to keep going higher. But there's no consistent period here. There's nothing that repeats itself over and over. Okay, so, I mean, we might continue on and go higher, and then maybe, we get off the graph or something, but there's no repeating period here. So while this one was periodic, this one would not be. Okay, so this one shows how many hours of sunlight there are in the day. When the sun rises. And if you think about this, we just went through the winter solstice, which is the shortest day of the year. So the sun will rise probably very late in the year. And you'll know that that repeats every year, right about here. This is about 365 days. And so that same thing is going to be happening over and over again. Okay, this one is periodic as well, because you know what our seasons are like. With June 21st we get the longest day of the year, and every June 21st will be the longest day of the year, so the sun will rise the earliest on those days. Okay, and then we have one more here, the number of hours a senior 4 student spends on homework. Well, you know for yourself that this is not going to be periodic. There's no sort of repeating pattern. This will be dependent on how much homework you have or how many tests you have coming up. Okay, and it will not be, we're not going to be able to say, oh, look at, because of this on Saturday, if I look the next Saturday, it's going to be the same. Okay, we won't be able to make predictions from that, so that's not periodic. Okay, in each case, the graph shows a relation. There is a relationship in each graph. Over time, if the relation has similar patterns that are repeated, then we call those periodic. Okay, because that repeated interval is called a period. Okay, so that's an introduction. Let's take a look at 4 examples here and try to decide which ones are periodic. So let's try number 1. It says the height of a bungee jumper above the ground as she jumps from a platform. So the graph will have height and time. And it says we start at 80 meters, or is it 80 feet? Okay, and if you think about the bungee jumper, they're going, as time goes on, they're going to come down, they're going to almost hit the ground, go back up. Now you're not going to go back up to the height that you jumped, but every one of these will be shorter. It would look something like that if you were on a bungee cord. Eventually you would stop bouncing. This is not periodic because we can't take a section and say, hey, this is going to repeat again and again. Okay, so not periodic. Let's try the next one. The depth of water in an ocean harbor. So again, we'll make a graph here. Depth, time. Notice I'm starting at time is 0. I'm not continuing the graph this way. And I always think of the Bay of Fundy whenever I think about ocean tides, because that's the biggest tide in the entire world. The depth of water change is greater in the Bay of Fundy than anywhere else in the world. So the way tide works is when the tide is in, then the water is high, and then as the tide goes out, the water recedes. In this case, the depth of water varies from 12 feet up to 18 feet, and as time goes on, it's going to keep doing this. We can make predictions that during this time, the water will rise and fall, and the next day, exactly the same thing will happen. Okay, this is periodic, a repeating pattern that happens over and over again. Alright, let's look at the third one. So here we have a piston in an engine. And if you know anything about engines, they have sort of a cylinder here with an arm, and this cylinder goes up and down, and you have a little bit of what's going on here? You have the spark plug up here that sends a little spark, and it causes an explosion which pushes the piston down. And a piston in an engine will keep going up and down, up and down. Okay, and it says in this case that it's going to go from 0.5 to 6 centimeters. So this is the height, and this is over time. Okay, and this is a little bit crazy, but it does this 1,200 times in a minute, 1,200 revolutions per minute. So it's going to go up and down 1,200 times in 1 minute. So if we went to 1 minute, it will have done that 1,200 times. Okay, again, that's periodic. Something's happening over and over and over again, and you can see that the pattern continues. Okay, last one. So this is a rural mailman will drive from one mailbox to the next. So this is going to be velocity versus time. So velocity is like speed. And so if you think about this, this guy is going to be driving around the road, and he's going to get to different mailboxes. Now, they're not going to be equally spread out. So he might be going 100 kilometers an hour, and then he's going to slow down to this mailbox and stop there, put the mail in, and then he's going to speed up again and take off. Now, he might only be there for a short time before he right away gets to the next one. Now, the next mailbox might be so close, he actually doesn't get up to speed. Okay, and then he might have to travel for a long time before he gets to the next mailbox. This you should see is not periodic because there's no consistent pattern. Okay, so those are some examples of periodic graphs and not periodic graphs. We're going to look at another example. We'll skip this one. Let's go to the one that we're going to spend most of our time on, the sine and the cosine graphs. Okay, so what I'm going to get you to do is use your calculator. You're going to pause the video here for a second and use your calculator. Let me show you the first one. It says 0 degrees, so I'm going to go here and I'm going to press, just 1 second, I'm going to say what is sine of 0, and it should be 0. Okay, now just before you go any further, go to mode and check here to make sure that you are in degree mode and not radian mode. See, I could change it to radians, but we're going to do this one in degree mode. Okay, so pause the video and I want you to fill this in. Okay, so I'll put 1 here and -1 here, and so at 0 degrees we have sine is 0. At 30 degrees, so this is 30 degrees, sine is 0.5. At 60 degrees, it's 0.86, and at 90, it's 1. And I'm going to continue plotting this. And you're going to see it makes a pretty interesting curve. So this is negative 0.5, negative 0.866, negative 1. And we get this curve that looks like this. Okay. Now we did this one by hand. You could have also graphed this using the calculator. So let me quickly pull up my calculator here. And I want to show you how to graph that. So let's go to y equals, and I'm going to press sine x. Okay, now it's a little different here. You don't go zoom 6. We're going to go to zoom, and if you look at number 7, it's zoom trig. And you get this graph. And you can see that it goes back and forth a bit more than ours does. Like we only looked at from 0 to 360 here. You know, if we continued on here all the way to 720 degrees, this graph would happen again, because it's periodic. It happens over and over again. Okay, so that's our graph, y equals sine of x, or y equals sine of theta. Okay, let's do the same thing now for the cos graph. So again, pause your video and fill this in. So use cosine. Okay, so if we put those values in, let's call this 1, call this negative 1, the graph is going to look very similar, but a little bit different. Okay, so again, we'll connect the dots. Oops. And we get that. Okay, there is your graph of y equals cos of x. We'll spend lots of time speaking about the characteristics of that, but for now, let's understand that this is a periodic graph. And we call it a sinusoidal graph because this graph will repeat itself over and over and over again. Okay, so go ahead and try this homework assignment, and we will continue with this next lesson.